All right, secondary math 2. We are going to be practicing factoring quadratics some more today, but we're actually going to do a little bit of review on multiplying binomials, okay? We can use FOIL or we can use the box method. Okay, so let's go ahead and review that because the first half of our notes, let me zoom out a little bit. Okay, so 1 through 4, think of that as like tying your shoe. Okay, we're gonna go from here to a quadratic. Okay, well then if we go down here to 9 through 12, these guys are like untying the shoe. We're going backwards, so we're going from a quadratic to two binomials. Okay, so that's what we're gonna review really quick. So let's look at number 1. So let's go ahead and use FOIL on number 1. Okay, so if I'm gonna use FOIL for number 1, that means that my FOIL stands for, in fact, I'll write that on the side of our paper. Let's go ahead and write it over here. So we have FOIL that stands for first, outside, whoops, might wanna spell it right, inside, and last. Okay, first, outside, inside, last. Okay, so if we're gonna use FOIL on number 1, we need to first multiply our first terms. Okay, so our first terms in these are 3n and 3n. So I'm going to multiply 3n times 3n. Okay, well 3 times 3 is going to give me 9. And 2 n's being multiplied, n times n, gives me n squared. Okay, so that's what we got when we multiplied the first terms together. Okay, now we need to do O. So what does O stand for in FOIL? It's going to be our outside terms. Okay, so on the outside are going to be 3n and negative 5. So we have 3n times negative 5. Okay, well here we can say 3 times negative 5 is negative 15. And there was one n that was being multiplied, so negative 15n. Okay, now we have our I in FOIL, that stands for inside. So if these guys are my outside, that means these guys are my inside. So I have negative 3 times 3n. Okay, well negative 3 times 3 is going to give me negative 9. And there was one n that was being multiplied, so negative 9n. Okay, and now we have our L, which stands for last, which is negative 3 times negative 5. Okay, well, negative times a negative gives me a positive. 3 times 5 gives me 15. Okay, and we're not quite done because we now need to combine like terms, but we know it's these middle guys because they both have just one n. So negative 15 minus 9 is going to give me negative 24. And then put the plus 15 on the end, the 9n squared in the beginning, and there is our quadratic. Okay, so let's do FOIL again on number 2. Okay, so F in FOIL stands for first. So we're going to multiply our first terms together, 2r times 3r. 2 times 3 is going to give me 6. Okay, r times r, or 2r's, is r squared. Okay, so there's our F in FOIL. Now we need to do our O. So outside is 2r times positive 4. So 2 times 4 is positive 8. There was one r being multiplied, so positive 8r. Okay, now we need to do our inside. Negative 1 times 3r. Negative 1 times 3, negative 3, and there's 1r. Okay, and finally our L for last, negative 1 times positive 4. So negative 1 times positive 4, it's going to give me negative 4. Okay, very last step, we need to combine like terms. So we have 8r minus 3r. So what is 8 minus 3? It's going to give me 5r in the middle, minus 4 on the end, 6r squared, in the front. Okay, make sure you put that positive because it's a positive 5r. And there's our answer. Okay, so if you guys remember, FOIL was not the only method we used. We also used the box method. Okay, so let's go ahead and use the box method for number 3. So we're going to draw our box here, okay, with 4 squares in it. Okay, so on top, I'm going to take my first binomial and put it on top. So I have 4p minus 1 on top. Okay, and I'm going to take my second binomial and put it down the side. 4p minus 5. Okay, well now I'm just going to fill in the boxes by multiplying them. So my first box right here lines up with 4p times 4p. Well, I know 4 times 4 gives me, 16. 2 p's being multiplied together gives me p squared. Okay, my next box lines up with -1 and 4p. So -1 times 4, -4, 1p being multiplied, so -4p. Okay, let's do our next box. We have 4p times -5. So -5 times 4 gives me -20. 1p being multiplied, so -20p. Alrighty, and finally our last box lines up with -1 times -5. Okay, we have a negative times a negative, which is going to give me a positive, and 1 times 5 is just 5, so positive 5. Okay, well now I'm just going to rewrite these guys in the order in which we solve them. So 16p squared minus 4p minus 20p and plus 5. Okay, and very last step, let's combine our like terms. It's going to be these two guys in the middle because they both only have the 1p. Okay, so we know that -4 minus 20 more is going to give me -24p. Okay, bring down your plus 5 and your 16p squared. And there's our answer, our quadratic expression. Okay, let's do the box method one more time for number 4. Okay, so we're going to draw our box right here. 4 squares inside. Okay, I'm going to write my first binomial on top, so 3n plus 4. And I'm going to write my second binomial down the side, 3n minus 2. Okay, now we can go ahead and fill in these boxes. So 3n times 3n, 3 times 3 is going to give me 9. 2 n's is n squared. Okay, now I have my next box, 4 times 3n. So 3 times 4 gives me 12. 1 n right there, so 12n. Okay, next box, -2 times 3n. -2 times 3 is going to give me -6 with 1 n right there. And finally, we have 4 times -2. So negative times a positive gives me a negative. 4 times 2 is 8. Okay, so now I can go ahead and rewrite these guys in the order in which we solve them. So 9n squared, 9n squared. Okay, it's a positive 12n, so plus 12n minus or -6n and minus 8. Okay, last step, let's combine like terms. It's these two guys in the middle because they both just have the 1 n's. So what is 12 minus 6? 12 take away 6. It's going to give me 6n, okay, minus 8 on the end, and 9n squared with a positive since it's plus 6n. And there's our quadratic expression. Okay, so let's look at numbers 5 through 8. So now we're kind of warming up to go backwards. We're gonna try and untie the shoe. So a big part of that is finding the greatest common factor. So for 5 through 8, we're gonna create our factor lists. Okay, so let's do a factor list for 14 and for 21. Okay, and we're trying to find the greatest common factor, the biggest number that's on both of these lists. Okay, so what are my factor pairs for 14? We know that 1 times 14 will give us 14. Okay, 2 times 7. 3 does not go into 14 evenly. 4 does not go into 14 evenly. 3 does not go into 14 evenly. 5, no. 6, no. 7, yes. We already got it. So we're done. Okay, those are our only factor pairs for 14. Okay, now let's do 21. So we can always start with 1 times itself, so 1 times 21. Okay, 21 is not an even number, so we know 2 doesn't go into it. But what about 3? 3 times what gives me 21? 3 times 7. Okay, 4 does not go into it. 5, no. 6, no. 7, yes. We already got it. So these are our only factor pairs of 21. Okay, so what's my greatest common factor? What's the biggest number that's on both these lists? Okay, so go backwards. Is 14 on both the lists? Nope. 21's not on both the lists. What about 7? Yes. So 7 is our biggest number on both of those lists. So we know that our GCF, or greatest common factor, of 14 and 21 is 7. Okay. So let's look at 6. So let's do the same thing. We have 9 and 45. Okay, so factor list for 9, we have 1 times 9. 2 doesn't go into it. 3 does. 3 times what gives me 9? 3. We already have it, so we're good. Okay, let's do 45. 1 times 45. Okay, it's not even, so 2 doesn't go into it. 3, yes, 3 goes into it. 3 times what gives me 45? 3 times 15. Okay, 4, no. 5, yes. 5 times what gives me 45? 5 times 9. Okay, 6, no. 7, no. 8, no. 9, yes. We already have it, so we're good. Okay, so what is the biggest number that's on both of these lists? Okay, what about 9? Is 9 on both the lists? Yes, it is. Okay, so we know that our GCF of 9 and 45 is 9, because 9 goes into 9, and 9 also goes into 45. Nice. Okay, let's look at 20 and 60. So for 20 and 60, I want us to do a trick. Okay, so the first trick you should do, in fact, let's write out this trick. Okay, does the smaller number go into the bigger number? Okay, divide smaller by bigger. Okay, if it does, if 20 goes into 60 evenly, then we know that 20 is the GCF. Okay, so we're going to go ahead and divide 60 divided by 20. Okay, we don't need those. I didn't need to write them. Okay, 60 divided by 20. Does this give us a whole number with no decimals? Okay, 60 divided by 20. Yes, it does. Okay, so this gives us a 3. So since it divided evenly, we know that 20 is our GCF. Okay, because 20 goes into 20, but 20 also goes into 60. So that is the biggest number that goes into both. Okay, so that's a little trick you can use. Okay, number 8, 16, and 24. So let's try using the trick on this one. Okay, let's take the bigger one, 24 divided by 16. Ooh, see, that doesn't work because it gives us a decimal. It's 1.5. So we know that 16 is not our GCF. Okay, so we're gonna have to use our factor lists to find this one. Okay, so let's do 16 and 24. Okay, so for 16, we have 1 times 16. We have 2 times 8. 3 doesn't go into 16. 4 goes into 16. How many times? 4 times 4, so we're done. Okay, let's do 24. 1 times 24. 2 times 12 will give me 24. 3 times 8 will give me 24. And 4 times 6 will give me 24. 5 doesn't, 6 does, so we know we're done. Okay, so what's our GCF of 16 and 24? 16's not on both lists. 8, is 8 on both lists? Yep. So we know that 8 is our GCF of 16 and 24. Okay. So now that we've practiced foiling to get quadratics, okay, this is like tying the shoe, and we've practiced finding the GCF, let's go ahead and factor quadratics. Okay, so when we're factoring quadratics, we always want to look at the last term. Okay, the last term is our 12. Okay, so we need to do a factor list for 12, but we need it to add to positive 8. We need these factors from our list to add to positive 8. Okay, so let's just try finding the factors. Okay, what is 1 plus 12 equal to? That's going to give me 13. Nope, that's not it. We're looking for 8. Okay, what about 2 times 6? What does this add to? Bingo, we got it. Okay, so we found which two factors add to our middle term, which is 8. So now that we found that, all we need to do is write our 2 parentheses. Okay, they look just like up here before we foiled them. Okay, we add our parentheses. Then we're going to put our variable, which is m, and an m in front. And then our last step is fill in our numbers that we found. It's a positive 2, so plus 2, and a positive 6, plus 6. And there we go. We factored it. Okay, we found the factors of 12, so they multiplied to give me 12, but they added to give me 8. Okay, let's do it again. So our last term that we're looking at is 63. Okay, so we need factors of 63 that are going to add to what? 16. Okay, so I probably know 1 and 63. 1 times 63 is not going to give me 16. That's going to give me 64, not even close. Okay, 2 doesn't go into 63. What about 3 and 63? What is 63 divided by 3? Okay, 3 and 21 might be getting a little closer, but that's going to give us 24, so no. Okay, 63 doesn't, or 4 doesn't go into 63. What about 5? No. 6, no. 63 divided by 6 gives me a decimal, so no. 63 divided by 7. Ooh, okay. So what about 7 and 9? Okay, what is 7 plus 9? Bingo, we found it. Okay, so we found the 2 pairs that add to our middle term, which was 16. So now we did that. We can write our parentheses. Okay, put your variable in front. K and a K. And now fill in your numbers. Okay, so it was a positive 7, so plus 7, and positive 9, so plus 9. Okay, and there we go, we factored it. Alrighty, let's look at number 11, because this one's kind of different. This one's a little tricky. So what is our last term we're looking at? This is going to be 7. Okay, so there aren't many factors of 7. Okay, but we need it to add up to a negative 8. Okay, so my only factors of 7 are 1 and 7. Okay, and what is 1 plus 7? That's positive 8. No, that's not going to work. Okay, so here's the really important part. In fact, I want us to star this right here. Okay, we know that to get a positive, we can also multiply a negative times a negative. Okay, so I can multiply -1 times -7 to get +7. That checks out. Okay, so now what is -1 minus 7? Bingo, we found it. Okay, so remember, negatives and a negative will give you a positive. Okay, so don't exclude those if you're looking for a negative number in the middle. But now that we found it, we can go ahead and write our parentheses. Okay, put your variable in front, a and a. And this time it's -1, so -1, -7, -7. And we factored it. Okay, let's do one more, because this one's kind of like number 11. So let's look at our last number. It's 28. So we need factors of 28, but it needs to add to a -11 again. So we might have to use some negatives here. Okay, I know that 1 times 28 is going to give me 29. That's not even close to -11. Okay, so maybe let's think of some others. Okay, what about 3 times 8? Okay, what does 3 plus 8 give me? Okay, that's going to give me 11, but is it -11? Nope. But remember, a negative times a negative gives me a positive. And actually, 3 times 8, right? Did I do that right? I might actually have done that wrong. Yep, I didn't do that one right. 3 times 8 actually gives me 24, not 28, so good one. This is supposed to be 4 and a 7. There we go. Okay, I know that's messy. So 4 times 7 will give me 11 now. So let's change this into a -4 and a -7. Hopefully you guys caught that if you were watching this. Okay, so now that I fixed it, we now know that it's a -11. So check, we found them. Okay, see, even the teachers make mistakes. Okay, so now that we found them, let's go ahead and write our parentheses. Put your variable in front, x and an x, and fill in the numbers that we found. Okay, so x minus 4 for -4, x minus 7 for -7. And that is factored. Okay, those are your notes for today, you guys. Make sure you do the assignment on Canvas.